Okay, today we're going to talk about our third tab of the foldable labeled arc and arc measures, and this is the Unit 15 foldable on circles. And today what I'm going to do is I'm just going to go over certain relationships between arcs and angles. We're not going to really do any examples in the foldable per se, but you're going to be able to relate them to each of these measurements that are related to arcs and angles. Okay, we're going to have about 5 slides or so. You don't need to write this one down, but just looking at it, when they're talking about an arc, if you look up here, the red part is the arc that they're talking about. The angle that it makes is down here. I'll draw it in green. So on each one of these, this is the angle that it's making. And what they're talking about is they're talking about the arc that's in the red, which is up here. So if you see that red part that I'm putting right below the green, that's what they're referring to. So we're going to find measures of missing arcs and missing angles. And you're basically going to have 4 different types of problems that show up. And that's what we're going to take a look at today. Okay, the first one we're going to look at is when you have an angle that's actually in the middle of the graph. So if you look right here, my angle is right in the center. Okay, they call that a central angle, and that's an angle with the vertex at the center of the circle. And the measure of the angle is equal to the measure of the intercepted arc. So right now, this angle right here goes up and it touches at point A and C. And so the arc that it makes across from it, I'm going to draw in green. So that's what they're talking about. And all they're saying here is that the measure of the angle is actually equal to the same measure at the arc. So pretty easy. When you got an angle right in the middle, right in the center, it's equal to the measure of the arc. So if this arc right here, for instance, was 40, that means this angle right here would be 40 degrees. Okay, they're the same length. That only happens when it's in the center, though, when the angle's in the center. Okay, the next angle here they call an inscribed angle. Inscribed means inside, so it's an angle drawn inside of the circle. But notice on this one that the angle made has a vertex that's actually on the circle. The last one we had a vertex right in the center. This one's actually touching the other side of the circle. So here's my angle. Okay. Here's the arc that it creates. Okay. And when you got one that has an arc on the outside with the angle touching the other side of the circle, if you read this, the measure of the angle is half the measure of the arc. So pretty easy. If this right here, let's say, was 50, okay, then the angle made is half of that. So that would be 25 degrees. Okay, that only happens again when you have an inscribed angle in which the vertex right here is on one side of the circle and it intercepts the other side at an arc on the opposite side. Okay, this is our third example that we're talking about, and this is called an exterior angle. Okay, exterior we know means outside, so they're talking about this angle right here. Okay, it's on the outside of the circle, it's not on the inside. And notice it says the angle whose vertex is outside the circle, like we talked about, and whose sides are tangent or cut through the circle. Okay, so notice how the sides are tangent. This means tangent right here when it just touches the circle, or it cuts through the circle like this side that I'm drawing right now. Okay, so that's what they're talking about on an exterior angle. And so it says the measure of this angle is half the difference of the intercepted arcs. Okay, so let me draw this. Here's the intercepted arc. So it goes from here, okay, all the way to here. That's what they're talking about on it. And what it's saying is if I put measures in there, like let's say that this one right here, which I will draw in black, draw that through. So let's say from here to here is 150. And let's say this one, which I will draw in blue, okay, this one right here, let's say that one is 60. Okay, so what it's saying is if you take 150 minus 60, okay, that's the difference of the two angles, 150 minus 60, you get 90. Okay, and when you subtract those, this angle right here is half of that. It's half the difference of those two angles. So half of 90 would equal 45 degrees. Okay, so this angle right here would have to be 45 degrees. It's half the difference of the other two angles made. Okay, our last angle that we're talking about today is called a circumscribed angle. That means An angle which you have two tangent lines that touch on the outside, so it's circumscribed. It's on the outside, so it's talking about that angle right there. Notice how these two lines are tangent. So that one and that one. And what they mean by tangent is it touches the circle at exactly one point there. Okay, it doesn't cut through it, just touches it. So what it's saying is the angle whose sides are tangent to the circle, the measure of the angle is supplementary to the central angle. Okay, we know supplementary means that both angles add up to 180 degrees. Okay, so let's make a central angle. So I'm going to go ahead and make one. So let's create one right here and here. And let's pretend that angle is 120 degrees. So this angle right here, angle B, is supplementary to that. So what angle would you add to 120 to make 180? You would add 60. Okay, so that'd have to be 60 because both of those add up to 180. And that's the definition of supplementary angles.